Hello, St. Mary's, and welcome to ACT Science. Stuff we do because we got to. All right, so let's talk a little bit about what is on the test. So, first, it is the last section of your ACT, which means that when people say, oh, it's hard, it's not actually hard, right? What's hard is that it's the last section of a relatively long test, and you've done some very challenging stuff. And so your brain's tired, right? On top of your brain being tired, here is the timing, right? You've got 35 minutes to answer 40 questions, which means you only have about 5 minutes per passage, which means you need to race through everything, right? The thing is that if you take an untimed ACT science passage, which you should find no matter your natural appreciation for science or math or any of those things, you'll find that none of those matter, right? That the test is really just a giant reading comprehension test, right? Which means that if you had infinite time, you could do very, very well, right? Anybody could do very, very well. But the reason it's hard is because one, your brain's already tired. Two, there is a huge time pressure in order to get all the questions answered, right? So that's why it's hard. All right, topics include a little bit of everything, right? So we've got some biology and chemistry, earth science, physics, all of which are really covered at the middle school level, right? So there is no expectation that you have taken biochem, physics, and earth science in high school to take the ACT and do well. Now, what is true is that on the entire ACT, out of all 40 questions, there might be anywhere between 2 and 4 questions that actually require science content knowledge. Like, you cannot answer the question from the passage. It assumes some knowledge that you've picked up in your science classes to date. And that knowledge is something that's going to be middle school level at its hardest, right? So yeah, if your goal is a perfect score, then yes, brushing up on some science might be helpful, right? But most of us don't have time to brush up on, quite that much science. So for most of us, that's not a realistic or good use of our time kind of thing to focus on. All right, what is a good thing to focus on, right, are the types of passages. So there are 3 general types of passages. One is our data representation, where you are given a whole bunch of data, right? Either as figures or tables or charts or diagrams or whatever they can come up with, right? And your job is to analyze the data, right? They also have research summaries where they can seem similar to data representation questions, right? In that data is often presented, but what's also presented is a whole bunch of information about the actual experiments themselves, right? And here, right, they are also looking for you to understand the purpose, method, and results and be able to compare and contrast between the different experiments, right? In addition to the other things they're asking of you, like analyzing the data, right? And then finally, we have our viewpoints passage, which is mostly here are 2 to 3 or 4 different perspectives on a science topic, right? Compare and contrast them. You typically aren't asked to evaluate the validity of them. You are just asked to compare and contrast them. So again, all it is it's a giant reading test, a tiring giant reading test. All right, so looking at our types of passages, right? So here is one of them. This is a data representation passage, right? Where if we take a look, right, it tells us this is passage number 1. It gives us some introductory information, right? And then all we see is table number 1. And we've got some information about some apples and some firmness and some days, right? We've got table number 2. Here are some apples again. And we've got some volatile abundance of apples. Okay. So here, if we have a data representation passage, the general strategy is don't read the passage, okay? For a data representation passage, the general strategy, and what we're going to talk about is the general strategy that works for most people. Obviously, as you practice, if it's not working for you, right, then come and chat, and we'll see what the holdup is and if there is a better strategy for you, right? But generally, the advice is don't read it, because understanding what's in there is not of the utmost importance. What is your ability to sift through the information in front of you, right? So what we'll do is we will just do what we did. We just highlighted the tables, right? So I know this is table 1 and that's table 2. and they're talking about some apples, right? So let's go and tackle some questions. So it says, suppose a grocery store wants to purchase a variety of apple that will retain as much of its initial firmness as possible when stored at 1 degree Celsius for 6 months. Based on Table 1, which of the 4 varieties tested would best meet the store's selection criterion? So we are going to look at Table 1 because that's what it told me to look at, right? And stored at 1 degree Celsius for 6 months. So 6 months is, right, 180 days. And which of the 4 varieties would meet the store's criterion? And we are trying to maintain firmness. So Table 1, 180 days, maintaining firmness, average firmness. So that would give us this one, Fuji apples. The end, right? And so again, we don't have really any idea what's happening, and we don't care. We just answered the question, right? Same thing if we look at the next one, right? It says, in Table 2, was the initial average volatile abundance of Red Delicious greater than 2, less than 2, or equal to 2? So we are going to go look for Red Delicious. So here's our Red Delicious, and volatile substances or abundance was the initial, which would be this one, right? So it's asking, do you understand what initial means, which is 0 days in, right? Greater than, less than, and clearly it was greater than 2 mg per liter, right? And so this is typical of a data representation passage, right? Where we have, again, information presented to you in the form of tables, charts, graphs, etc. And you will just annotate the graphs or annotate the data just a little bit so you know like where to focus your eyes. And then you just tackle the questions. Odds are in any question set, there will be one that requires some information from up here, right? And you'll know because it's not in the table, right? So data representation. Next passage. All right. The next type is a research summary. So if we look at this as a comparison, right, we'll see that not only are we told the passage number, right, but we also have experiment labels in here, right? Oh, that's a big old clue, right? Which means that we are also getting some more information, not just about the data, right, but about what they're doing, right, in each of these different experiments. Now, let's say that we try to take the same strategy, right? Number 13 says, according to the results of experiment 2, so, we'll look there, soaking chickpeas in distilled water for what length of time and at what temperature resulted in the greatest absorption of water? Okay, so let's go look at experiment 2, chickpeas, distilled water, time and temp. So experiment 2, it says students repeated the procedure from experiment 1 at 4 other temperatures, right? And then we've got a CMU here, and I don't know what a CMU is. I do see soaking time and at a temperature of, and so it's like, oh, well, so now in order to answer the question, I actually need to go and consider what's in the other procedure, right? So I need to actually go back and look at experiment 1 and read it in order to have enough information to answer this question, right? And so if we go back here, it tells us, so we got some dried chickpeas, that's great. So we got 50 beans, and the total mass of the sample was measured, and the average initial mass is that the sample was immersed in 200 mils of water. After 20 minutes, they were removed, patted dry, mass was measured, average final mass, and so they kept removing chickpeas, and the average moisture uptake. So average moisture uptake was then calculated. So that means a bigger CMU, and we, write yourself a note, right? Bigger CMU means more water absorbed, right? So that's what we're looking for, right? So soaking time, CMU goes up. All right, so now we have what we need. So it says, according to the results of experiment 2, what length of time and temperature in the greatest absorbance? So we're looking for the greatest CMU, right? So we are just looking for the biggest number, and we already know that soaking time is going to matter, right? So we look at all of our data, and we would see that, indeed, highest temperature and highest amount of time, right? So it says 270 at 50, this is going to be our answer. Yes? If we look at number 14, it says, if a what's this? That's right, chemistry. If a 2 molar NaCl solution had been tested in experiment 3, the CMU at 90 would most likely have been, okay, so 2 molar sodium chloride, experiment 3. So we go look at experiment 3. It says the students repeated the procedure from experiment 1. Okay, we just read that, except that they replaced the water with sodium chloride at 3 different concentrations, right? So if we look here, we've got molarities of these. So then we would think to ourselves, oh, that's what they're checking, right? 2 molar would fall somewhere in between, right? So it's an extrapolation question, right? Where we are being asked 90 minutes. So that means we would go across here, right? And so 90 minutes would be somewhere in between those 2 values, right? So then we would go and find that answer. So between these 2 values, right? So anyway, the point is that if we have a research summary question, it's a good idea to just go ahead and read it, right? And we're not reading for like understanding everything, right? Like you don't need to necessarily like sit here and stumble over average initial mass per chickpea and like you don't need to understand all of that, right? So just like what I just did with you, right, was I read it so that way I would get the gist of it, right? And I took away that the CMU, bigger is better, right? Well, bigger means more water. I guess better depends on what we're trying to figure out, right? And then this table is enough to give me a quick perspective on soak time correlates with an increasing CMU, right? Which then helps me as I assess the rest of the questions, right? So anyway, research summary. Last type of passage is the viewpoints passage. So the big clue when you get there will be, here is 1, here is 2. There are often few figures or no figures, and if there is a figure, usually it's just something to clarify what it is that the people will be discussing. Sometimes it's scientist perspectives, sometimes it's student perspectives. It varies in the passage. And again, the goal here is not to assess the validity of the science, right? Because sometimes it's just straight up weird science or it's science beyond what you've covered, right? And some of them are just flat out wrong, right? I mean, that's just what's going to happen if you present 4 different ways to look at any given science topic, right? But again, it's about comparing and contrasting. What do they say that's the same? What do they say that's different, right? So what we would do is we would read the whole thing, and that's what we would look for, right? And we would take very good annotations because those are the things that are going to, 1, help the ideas stick in your short-term memory long enough to use them for answering the questions, right? 2, if you have forgotten it, right, that should jog your memory when you look at it to help you answer the questions more quickly, right? And with a better understanding. So you would read the introduction, which says, in that area of Mars's surface, numerous wind channels are visible. The channels, some of which are 100 kilometers long, were formed more than 3 billion years ago. And here's the abbreviation they'll use for that. 2 scientists discuss whether these channels were formed by liquid water or liquid CO2. All right, so that's what we'll be discussing. So scientist 1 says, unlike today, Mars was warm enough prior to 3 billion years ago for liquid water to exist on the surface. So warm enough for liquid water to exist on the surface. Prior to the formation of the channels, a large volume of liquid water slowly accumulated within a basin within the place. Once the volume became great enough, the liquid water was released suddenly from the basin. The rapidly flowing liquid carried away rocks and soil, forming the channels. On Earth, similar features, called outflow channels, are produced by the sudden release of a large volume of liquid water from a basin. Gray hematite is abundant on Mars's surface. On Earth, the mineral is associated exclusively, so hematite is exclusively associated with liquid water. Even today, large quantities of frozen water are still present in Mars's polar regions, right? So scientist 1 is definitely liquid water, right? We've got a basin, and we've got channels, right? And we've got hematite. And also of note, I guess, is that it's warm, right? Okay, so then scientist number 2 says, let's see what they say. Scientist number 2 says, before 3 billion years ago, large volumes of CO2 gas were present, short distance below the surface. In there, eventually the subsurface pressure, due to the weight of the rocks, became great enough to change CO2 to a liquid. When a later major event, such as an asteroid impact, removed most of the overlying material, the liquid CO2 quickly moved up and then along the surface. The rapidly flowing liquid CO2 carried away rocks and soil, right? So there's a repeating theme, forming the channels. On Earth, gases or liquids that have been under pressure below ground are released to the surface during some volcanic eruptions. These pyroclastic flows move rapidly along the ground, forming channels. Since Mars's formation, its average surface temperature has never been greater than -50. So that's a key point, right? This has made it impossible for a significant amount of liquid water to be present on the surface. If any liquid water had been present on Mars's surface, it would have reacted with CO2 to produce carbonate rock, a rock composed of carbonate minerals. No carbonate rock has ever been found on Mars. Okay. So here we've got CO2 gas, which then turns into CO2 liquid, and then we get channels. And let's see, it says that it's cold, always cold, and no carbonate rock. So those are points of reference for ourselves as we go and approach the questions. So number 3 says, both scientists describe how a flowing liquid formed the channels that are more than 3 billion years old. The process described by each scientist is an example of. Here is a science knowledge question, right? In that neither scientist addresses what that process is called. It's just assumed that this is a science topic that you have picked up on during the course of your science education. And hopefully you have. All right, number 35 says a study concluded that at all times before 3 billion years ago, the temperature and pressure a short distance below Mars's surface would have allowed liquid water to exist, but would not have allowed liquid CO2 to exist. This finding is inconsistent with the discussions of which of the scientists of either, right? So which scientist does this not corroborate, right? So it says at all times below the surface would have allowed liquid water, but not liquid CO2. So this refutes scientist number 2, right? Because scientist number 2 said that CO2 existed just below the surface until it was freed by the meteor or something like that. All right. Number 36, consider scientist 1 and scientist 2's assertion that the source of the liquid that forms the channels in the place, according to scientist 1, was the source on the surface or below the surface, and science 2 was the source on the surface or below the surface. So here, it's just, did you pay enough attention that you can differentiate the two of them, right? And scientist 1 said it was on the surface, so we would narrow it down here, right? And scientist 2 said it's below the surface, which would then give us this as our correct answer, right? Okay. So anyway, that's the viewpoints passage. Okay, scoring and how does it work? So for the science test, right, it is a difficult score, right? In that here, what this says is you had to get perfect or almost perfect to get a perfect score. On a really hard test, it is 40, right? It would just say you had to get literally a perfect score to get a 36, right? And so anyway, that's how the scaling works, right? But note that even, for example, let's say if you were shooting for a 28, right? 28 means you had to get 32 questions right. That means there are 8 questions that you could miss. And whether that's 8 that you missed because you didn't have time or 8 that you missed because you just didn't know what was happening, right? That's fine, right? And that's why there is some flexibility, right? What I'm giving you is the best general method, and we can talk about ways to tweak it for you, right? Depending on what your score goals are. All right. Finally, tips for success. 1 is practice, right? I can't emphasize enough, right? So there is the surface level justification that says, the science test is easy. Yeah, if you had infinite time, right? And there's the fact that, oh, well, there's no real science on there, so what good is practicing or studying? Well, the thing is that the question types are predictable, right? After you've taken 3 of them, you will have seen all the question types a multitude of times. And by seeing them repeatedly, you will get more practiced at what to expect from the question, right? Like, for example, on these other questions, like how to compare what the 2 different scientists are saying, right? Or on some of these other questions, how to extrapolate a data point like we did here, right? Those are questions where they show up over and over again on the ACT, and the more you've practiced, the better you will be at answering those questions, right? So because question types are predictable, practice is an invaluable tool for improving your score if that's something you're trying to do, right? Annotations are important, right? Some of you guys are like, I don't need that. Well, actually, that's one of those things that's going to really, really help with your reading comprehension, right? I mean, that's the reason your English teachers tell you to do it, right? They're not just like wasting their time and energy and breath, right? So do it, right? And then sleep, obviously, because it is the last section of a long test, and the better rested your brain is, the sharper it will still be at that point in the day, right? And so there's little you can do about that except for, practicing good basics like getting a good night of sleep. All right, that's all we got. Thank you for listening. Be good, and I will see you soon. Bye.